Most people call me Hoots. At Starbucks, for some reason, they decided to call me Steve. I guess that's what you get for ordering pumpkin spice lattes. So first of all, what is Felix Gray? Some people don't know what that is. We're essentially an eyewear company that sells glasses that mitigate the negative effects of looking at your screen. We essentially filter the blue light that comes from your devices, and it makes it easier for you to work on your screen all day. You don't get any blurry vision, headaches, sleep disturbances, and they're actually really cool looking to wear. So I'm going to talk to you today about why we decided to move to Aurora and kind of the story behind how that all happened, the troubles that we went through, the lessons that we learned, handling failovers, figuring out what type of instances you need, and then finally going over and optimizing and figuring out what a better way is of making our infrastructure more reliable. So we decided to go to Aurora because it was just by default much faster than MySQL, and we started to scale up and we started to see our queries start to slow down. So we looked at other solutions that would mitigate that effect. We looked at going to NoSQL, but our data wasn't exactly very lookup oriented, it was very structured. So going to Aurora seemed like the next best option. It also was very nice with data sizes. You can pretty much provision any size you want, and the database size increments by 10 gigabytes. Now, my favorite feature right now is backtrack. If you're doing testing, it's something you could just roll back the database by like X number of hours and go back to the state that it was originally in. So you could run your tests, then roll back, and now you're back to where you were. You don't have to go to a snapshot, reload it, and then wait another 40 minutes for that instance to spin up. Automatic snapshots, RDS by default has that, but it's also really cool. Zero downtime patching is also really cool. The asterisk there is because it's not technically zero downtime patching, as I learned. It does go down for a few seconds depending on what it's doing. It tries to find a window in where it can kind of figure out to patch the system, and it kind of takes the system down for about 2 to 3 seconds, loads it up, and then it kind of holds your queries while that is happening. It's extremely cost effective, especially if you're using reserved instances. That's my main key point, is make sure you use reserved instances once you figure out the size you need, because that saves you about 45% on your AWS costs. 2 new things that just came out, serverless, that's really cool if you're trying to save on money. And if you have an application that doesn't need to run 24 hours a day, our website needs to run like every second, so I can't really use, it doesn't make much sense to use serverless. But if you're running an API or something that people hit like every 10 minutes, it probably makes sense to try your serverless configuration. Now, parallel queries, that's really cool too. If you have something that you're doing a lot of data analysis for, parallel queries can help you with that. You could do them for like long running queries. You don't need to have like a Redshift instance. That way, it makes it a lot easier for you to just spin up a read replica and do parallel queries. So migrating to Aurora, step 1. I'm going to kind of go through and show you how easy it is to do this. It only takes about 6 steps, and it takes about 5 minutes normally. Except when I did this about a year ago, this was when Amazon decided to change their user interface at the point of me doing my migration. And I was doing this at 3 a.m. So when I got up to this step and I hit create instance, nothing happened. So I waited about 10 minutes. And I realized that as I pressed refresh, nothing was still happening. So I called up AWS support. And something interesting happens when you call AWS support at 3 a.m. Someone in Australia picks up. And the dude was like, "Oh, good day, mate." And I was like, "No, it is not a good day. I'm talking to you right now." So we went through it, and then he told me that I have to go through the terminal to actually do this migration. And unlike most developers, I know this is different for most people, but I hate the terminal. I'm probably one of the only people that uses GitHub Desktop, and a lot of my employees give me a lot of slack for that. So once you get through that, you'll see that it'll start creating the instance for you. And now we'll wait. It takes about 30 to 35 minutes for this to happen. So you're going to probably need to wait about 30 minutes. But the good part about that is that once that's happening, your master is still up. So your application can still be running. You don't have to worry about taking your application down and then worrying about downtime or anything. So the key factor here is that make sure the lag is 0. You'll see that if you look up bin log in the CloudWatch area of your thing, make sure that hits 0. That's when you know your replica has matched the master in lag. So it has the same amount of data and the same rows and queries. Step 4, you go and you select your master instance, and now you can stop it. So step 5 here, you can take the, sorry, my mistake. What I meant to say is once you go here, stop it, and then over here, you can promote this to the master, promote the read replica, the button right over here, and that will make it into a master. Now, a few caveats to that is make sure you go into your application and change the endpoint to the Aurora clusters writer endpoint, not the individual instance of Aurora, because Aurora has individual instances. You don't want to use that endpoint, because if there's a failover, as I learned the hard way, it will actually not change the endpoint for you. So you want to use the Aurora cluster endpoints, and you could see that in the menus. So handling failovers, the most important thing is make sure you have your instances in multiple availability zones and have at least 1 or 2 read replicas in each zone. Now you can actually do multi-regions, so it's a good idea maybe to have another region if your budget allows that. And test this by promoting one of your read replicas to master and see what happens. Make sure that you're ready for this failover. And another thing I learned the hard way is that most drivers by default don't support the Aurora failover. And the reason behind that is that the value, the CNAME of the database is still pointing to the master instance. So what you have to do is, if you're doing Rails, for example, there is a patch that you can use that kind of goes through and checks the connections and then tries to figure out what to do next. It'll give you there'll be about 5 seconds of downtime, but you'll definitely be back up and running. If you're using Go, I believe they fixed the issue actually. So if you're using that language, you're all set. Node.js, I'm not sure if they fixed it yet. That's still an issue there as well. So you want to figure out the instance size that you're going to use, because that's kind of the best way of figuring out what everything's going to cost and what you're going to do. So think about the number of connections your database has from your application. Most applications in production environments have a connection pool, so figure out what your connection pool size is. So for example, if you have 4 application servers, each with a connection pool size of 15, how many connections do you think you would have? And the answer is simple math, 60. So here's the AWS formula for figuring out the instance size based on the number of connections you need. Just kidding, they actually have a nice table that you could Google. It takes about 30 minutes to Google and find that, but it's there. Now, you'll see that T2s only support a very limited number of connection. And you can go into the parameter groups and change the max connection size if you really need to, but I really don't recommend it. These are actually really good numbers to support the load on the database. And that brings me to my next point, is always use R-class instances in production. I know they cost a little more, but they definitely support it if your application starts to scale rapidly. I was being very frugal, let's say, and decided to stick with T2 in production for a while. And then what really happened is that really happened. As new instances started to auto-scale, they started to fail. And the reason before I even got the CloudWatch alerts, customer service started yelling and screaming that the site is down and that they can go home now. So I already had 2 heart attacks and a stroke by the time the CloudWatch alerts came in. So make sure you do that. And what actually happened is our application auto-scaled to 10 EC2 instances, and the connection pool of each instance was about 10. T2 only kind of doesn't support that, as you saw earlier. And the other problem was some of our pages actually took about 20 to 30 SQL queries to just load. That is not a good way to run a production scale application. It's something I wasn't really paying attention to. I kind of saw that, but it was just like, all right, we'll deal with it later. Until later came along and we had about 2,000 to 3,000 people on our site at one point. So finding performance bottlenecks, you're going to need to use a tool. New Relic is a really great tool. They kind of go through and they show you some of your controllers and application areas where it's kind of lagging. And you'll see, for us, it lags right now in the production controller. Now, that's kind of this page where it kind of loads all the glasses, and you'll see they have different colors. So how can we fix that? Well, you'll see that if you click into it, there's a bunch of queries that happen that are really slow. Now, we have two options. If you know a query doesn't change, you should probably cache it. So if you're doing something like loading a page with the same number of products every time, cache that query. But if you're loading a cart that someone is adding and removing things, don't cache that query. That's a bad idea. So queries that don't change, here's a little code example in Rails. You'll see that we cache each individual property and individual product value. That way, when the page loads, it just gets cached, and it's a quick query to our Memcache servers. It doesn't even hit our RDS instance. The next step is if you can't cache something and you really need to simplify it, here are some basic rules. First of all, every time I see a select star, I get very nervous. Don't use select star. Always restrict to the number of columns that you really need. And then use aware whenever possible to restrict the number of rows that are returned. Sometimes it's easier to get things done in multiple queries, and especially if you could cache one, right? If we can cache the cart, for example, if we cache the whole query, we can't really do it. But if we could cache the product section and then do a separate query, then that kind of offloads the database load. Don't use temporary tables. Some people say you can use them with special caveats. I just say don't do it. It's a bad idea. And then finally, create indexes on the columns that you frequent the most. It's really important to make sure that queries that have like order by or any sort of complex queries that you're doing, that you're constantly doing lookups, make sure to index those columns. Other things to do that you could use to optimize your service is a bunch of other AWS services. I just talked about caching. Elasticache is a really great way to do quick lookups and cache your SQL queries. Elasticsearch is if you have like a search bar on your application, for example, and you're doing a lot of searching, have Elasticsearch kind of take the information in your database and store it in Elasticsearch. It's a faster lookup, and it also doesn't need to touch your database. And finally, if you're doing analytic stuff, if you have a data team, you want to look through queries that run for a long period of time, I would recommend using Redshift. And then obviously, if you're storing images, don't put them in your database. That's really not the best place to put them. S3, and then store a link to S3 in your database. So if you were to actually kind of put our infrastructure in a little simple model, this is kind of how it would look like. You have your EC2 instances. Elasticsearch does all the searching, and that just grabs stuff from one of the read replicas. Elasticache sits in front of Aurora, which grabs all the queries that don't change over time. And we store all of our images in S3 and serve them through CloudFront. So that's optimization that way. And then Redshift is for database and analytics. Another way you could optimize is kind of at the edge of your application. If you are doing stuff on website of things, or if you're doing an API, there's CloudFront and Cloudflare, which is not to be mistaken with CloudFront. This is a third-party service. They are technically free for like the first, I don't know how many usage, but they don't cost that much to run in a production environment either. I think it's about $100 or $200 a month. And they kind of manage all the security optimizations and DNS for you. It's really much easier to use than CloudFront. CloudFront's really cool too, but there is a lot of overhead in managing and figuring out what to do and what to use. So after going through all that, you'll see that our average response time from the beginning when we first started to look at all these database issues started to slowly trickle down, and now we're at about 2 to 2.5 seconds. So you can see there's a huge improvement as you start using other types of AWS services to offload your workload and figuring out what instance size you need. So overall, the conclusion is migrate to Aurora whenever possible. Always use your R-class instances in production. Make sure your connections won't be limited. I know this can be a little costly at first, but it will definitely save you a lot of heartache. And then profile your application to file any bottlenecks and use AWS Services to offload, load on your database. Thank you. So special thanks to the AWS Loft team for having me here. The migration blog post is here, and here's a 10% discount. If anyone has any questions, now would be the time.
For Elastic Cache, are you using the Memcache or Redis?
So we use both. We use Memcache for the query side of things, and we use Redis for job and background processing. But it depends what you're doing. Memcache, for example, if you're doing something that's HIPAA compliant or you need to store information that's sensitive, I would recommend Redis because that you can encrypt. Memcache you can't encrypt. So, but Memcache definitely is quicker and easier to set up. It's just like a few menu options where Redis is about like a little more, especially if you're doing encryption and things like that. Any other questions?
So you said you scale it up. Do you use any particular CloudWatch metric to scale it up, or what do you close?
Oh, you mean the EC2 instance?
Oh, yeah. Let me repeat the question for everybody. So yeah,
So we use, so it's a combination of different things. It's, it varies. It's based on the network load, the network traffic that we get. Okay. It's based on the number of hits per second. And then there's like a third thing, I don't remember exactly, but we have a combination of things. If any of those trigger, then scale up the instance.
This is not related to databases. Did you guys think about using Beanstalk? Or?
Yeah, we do use Beanstalk actually.
Okay. Instead of EC2s just directly?
Yeah, it's a Beanstalk configure. We're actually moving to containers soon. If you're actually a startup and you're trying to start to do things, I would recommend starting small. If you're doing a very small application, probably Lightsail, then graduate to Elastic Beanstalk, and then finally ECS. I think that's the very natural progression of things, because Lightsail is like really simple to set up, takes like 2 seconds. EB is a little more complicated, and ECS, don't even get me started.
On the same topic, what made you decide to move to containers from
to
Beanstalk?
containers? A few things. One is we need a little more configurability in our setup. The second part is that EB kind of doesn't handle all the things we need in our current infrastructure. It's hard to describe without going through our entire infrastructure and kind of telling you. But we also want to kind of do builds and deploy easily without having to create EB config files that have to set up each instance every time a new instance deploys. So if you start using Elastic Beanstalk, you'll realize that to configure the instance, because every time it auto-scales and adds a new instance, it's essentially rebuilding a new system for you. So you have to tell it what to do, what items it needs. So it turns into a configuration nightmare.
So how do you sync the data between MySQL or Postgres Aurora cluster and the Redshift?
Oh, that's a great question. So long story is there's no easy way of doing it. Actually, they just released a tool, I think it's called AWS Glue, which kind of goes through and takes all your data, puts it in S3 for you, then loads it into Redshift. There are a bunch of third-party services that do this for you and cost a small fee. But there's no like direct way of taking data from RDS and putting it to Redshift. That's why I was really looking into Aurora parallel queries. If you look into that, you'll see that it's kind of like a Redshift type thing where it lets you do a lot of the things that Redshift is supposed to do for you.
What do you do with security?
How do I deal with security? Well, I mean, I encrypt everything, so That's how I deal with it. But you don't have to encrypt everything by default, but I highly recommend that. And then make sure the connection from your application to RDS is encrypted and it uses the AWS certs.
I just want to jump in here for a second. Actually, if you need to get data from an RDS instance, Aurora, into Redshift, there is an AWS service that you could use if it fits your circumstances. The database migration service
Oh, I didn't know that.
will actually pull data out of RDS instances, and Redshift is an actual target for the service.
Learn something new every day.
So when you cache the query results, how do you choose between elastic cache and the built-in cache of the database?
Well, we chose Elastic Cache because it was the easiest thing to implement with Rails. So you could just kind of load a library and it kind of does everything for you. You can use stored procedures and a bunch of things if your database supports it, but that takes a lot of time and effort. EC is kind of like very easy to set up and easy to use. I guess I'll get everyone back to drinks and food. All right, thanks everyone.